Hi, this is a quick video that I'm going to use to explain how to do this problem. And in this one, what you need to do is you need to find out the moles of carbon dioxide. And to find the moles of carbon dioxide, you do mass over relative mass. And that should give you 0.025 moles of carbon dioxide. On the other side, you try and find out the moles of water. Once again, it's mass over relative mass. And that should give you, in terms of moles, .025. Now, if you look at the carbon dioxide, that should tell you how many moles of carbon there are. Okay, so the moles of carbon would be 0.025, and if you look at the water, that'll tell you how many moles. Oh well, okay, you can find out the mass of carbon there. So you just do 0.025 moles times by 12, which should give you 0.3 grams of carbon. And this is in the compound X. Right, so if you know the moles of water, you should know that the moles of hydrogen would be twice the number. So it's 2 times 0.25 rather, which should give you 0.05 moles of hydrogen. And therefore you can find the mass of hydrogen in compound X, which should be 0.05 times by 1, which equals 0.05 grams. So if you look at the original amount of substance, should be 0.43 of X. I've written 0.05, but it should be 0.03. That's my mistake. Sorry. I put 0.45, so that should be 0.43. I made a mistake there. But it does give you 0.08 grams of oxygen. So, sorry about that error. Where I've written 0.05, that should be 0.43. But because it's made up of carbon, hydrogen, oxygen, you can take away the mass of carbon, you can take away the mass of hydrogen, and that leaves you the mass of oxygen. And that can be converted into moles of oxygen by dividing by 16. So 0.08 divided by 16 is 0. I don't know why I've paused here. 0.005. Okay, so now you know the moles of carbon, the moles of hydrogen, and the moles of oxygen. So that's 0.025, and hydrogen is 0.05, and oxygen is 0.08. Sorry, 0.005. So it's 0.08 grams, which is 0.005 moles. Divide by the smallest, and you should get a ratio of 5 to 10 to 1. So that should give you C5, H10, O. There are other ways of doing this. I've seen it done with ratios, but that makes, you have to make an assumption there that it's only got one alcohol, which is a reasonable assumption at this level. It's quite a neat bit of ratio work, but this is probably the most effective way of doing it. And then obviously it's just once again of comparing the mass with the relative mass of one and with the relative mass from the question. and that should give you 5 times 12 is 60, 10 times 1 is 10, and 1 times 16 is 16, so that's 86. Right, the second question here that a lot of people struggle with was this question: when ammonium dichromate is added gradually to molten ammonium thiocyanate, a salt is formed. It has this formula here, and you've got 3 substances here, percentages by mass, but not enough really, because they don't tell you enough information here. But we can still work with what we've got here. So we found out the number of moles of chromium, so that's 15.5%. Remember, with percentages you can just use them as masses, divided by 52, 38.125 divided by 38.15 divided by 32, and 29.2 divided by 14, and find out the moles of each. That should equal 0.298 moles of chromium, and this one should be 1.19. Yep. And this last one is 2.09. Obviously, to find out the simplest ratio, divide by the smallest, which is 0.298. So 0.298 divided by 0.298 is easy, it's 1. The next one is 1.19 divided by 0.298. And the last one is 2.09 divided by 0.298. So if we bash those into the calculator, we've got a ratio of 1 we've just done. The next one is 3.99, which is about 4, almost exactly 4. We'll just use 4. And the last one is 7. Okay, so we've got a ratio of 1 to 4 to 7. It doesn't seem to help us at first until we have to sort of think sideways a bit, because we don't know the amount of carbon there, but we can think sideways here. We can think that the number of moles of sulfur is going to be the same number of moles of the thiocyanate, SCN. So SCN moles in this ratio is going to be the same as the sulfur moles, which equals 4, and that is the value of X. So X equals 4. That's straightforward. And then lastly, we look at, there are 7 nitrogens. Okay, 4 of the nitrogens are used in the thiocyanate. So we can take away 7 minus 4. One of them is used in the ammonia, the NH4, at the front there. So there's the thiocyanate. And there's the ammonia, using 1 of the nitrogens. So 7 minus 4 minus 1 means there's 2 nitrogens left, and those are the 2 nitrogens in the ammonia at the end. So therefore Y must equal 2.